volcanoes 800,000 years ago. And it's still growing at the rate of about a square mile every 20 years. And you can actually see that process happening right over there. Already, 20 miles to the south, 3,000 feet underwater, yet another volcano is being born. Lava is pouring out of the Earth's crust, creating what will be the next Hawaiian island. And in 200,000 years, that could be as big as the island that I'm standing on right now.
The creation of the entire chain of Hawaiian islands took 43 million years. But the Earth is 100 times as old as that. And in that amount of time, our entire planet has been transformed. From the time the Earth cooled, its rocky crust has always been on the move. Oceans and mountain ranges have been and gone. Our planet today is just a snapshot in time. 250 million years ago, the globe was very different. It was time that created the continents we recognize today. And time will continue to transform the Earth. But time has been crucial to another unique and extraordinary journey. Life. We are part of the most extraordinary story of all, part of the incredible diversity of life on our planet. So, what is our journey through time?
What I find remarkable is the fact that this journey is imprinted in me. My body is like a museum. My face, my features, my arms, my legs, all of them bear the scars of evolution. So if I could peer into my DNA, into my body, I could perhaps retrace the steps taken by my ancestors thousands of years ago. I could take my own journey through time.
All these marks of time are cataloged in my DNA, locked in every one of my cells. One part of my DNA, mitochondrial DNA, is the key to tracing my ancestry. This DNA links me to all the mothers of my past. How and when I became a Japanese American living in the 21st century, somehow it's all encoded right here. I'm sending it to a special lab in Cambridge. Geneticist Peter Forster has created a global map of human ancestry, all based on DNA. By checking my sample against his database, I'm hoping that he'll be able to find out where my ancient forebears came from. I've come to London to see what Peter's found.
I've been looking forward to this moment.
Hi, Richard. Pleased to meet you. I'm Peter Forster.
All right, how do you do?
Do take a seat.
Sure, so exciting.
So, the moment of truth.
What we've done for you is we've determined your mitochondrial DNA sequence. We can then trace your maternal ancestry back through the generations.
I see. I think my mother would be delighted to know this too.
The interesting thing is that in Japan, we only have about 3 hits in a sample size of over 1,000.
That's unusual, right?
Yeah, it's not a very usual lineage, in other words. Yeah, it's interesting to see that you have cousins, distant cousins, quite far away in and around Tibet.
Is that right?
Your maternal lineage, M9, has its highest frequency in Tibet of the area studied so far.
Wow, that's amazing, huh? Who would have thought?
Yeah.
So, life's full of surprises. I'm a Japanese American Tibetan living in New York. In fact, the same DNA connects us all. Back to the very first modern humans that evolved in Africa over 100,000 years ago. But what about before that? This reorganization of DNA lies at the heart of evolution.
Ever since people began to carefully look at rocks, they found inside them the remains of creatures embedded inside their layers. I like to think of this as being a time capsule written in stone. Now, the story of life is written in these fossils. For specimens like these, science has been able to piece together life's journey through time.
Because we can date the rocks, we can also date these trilobites. They lived over 500 million years ago, scuttling around the floor of some deep ocean. Fossils have allowed us to chart the evolutionary chain that led, by chance, to us. And it all began a staggeringly long time ago.
Now, the amazing thing is, when you look at older and older rock, you continue to see signs of life, all the way back to the earliest life forms, which are tiny little dots marking the presence of single-celled organisms. They date back to an incredible 3.5 billion years ago, back to the very beginning of life's journey.
To get a perspective of humanity's place in time, I'm making another journey. Starting from the beginning of Earth time right through to the present day. The first billion years of Earth time are lifeless. But then, no one knows exactly how, the first signs of life appear 3.5 billion years ago. These are our very first ancestors.
Now, for the next 2.5 billion years, not much really happens. The Earth is dominated by single-celled organisms, or bacteria. All they do is they live, they divide, and they die over and over and over again.
As time passes, it's incredible just how long it takes before life shows any sign of change at all. It's not until 570 million years ago that something amazing happens. There's an explosion of new life forms in the world's oceans. These are the ancestors of all living animals, fish, birds, even us. It isn't long before animals are everywhere on the planet. But it's not until around 5 million years ago that something remarkable happens in our journey. The first ape men appear.
This is about when our ancestors first left the jungles and forests of Africa to live in the grasslands and savannas. That's when our ancestors began to walk upright, which freed up